My name is Bob. Today I'm going to show you how to find the 4 centers of the triangle. We'll be finding the Orthocenter, the Incenter, the Circumcenter, and the Centroid.
The Orthocenter. The Orthocenter is the point where all 3 altitudes of the triangle intersect. There are 3 altitudes in the triangle for each vertex. In order to construct an orthocenter, you'll first put the leg of the compass on one of the vertices and on its opposite side draw an arc. Then, you use your new 2 vertices where the arc meets the side and create an arc facing the vertex you used to create the arc on the side. Use a straight edge to draw a line from the vertex to the arc. Use the same method for the rest of the 2 vertices on the triangle. When finished, you should have 3 lines meeting in one place, which is the orthocenter.
The circumcenter. Step 1. Draw the perpendicular bisector of the side AB. This can be done by placing the compass on one end of the line segment. Without changing the compass's width, draw an arc above and below the line. Place the compass's point on the other end of the line. Draw an arc above and below the line so that the 2 arcs cross the first 2. Using a straight edge, draw a line between the point where the arches intersect. Step 2. Draw the perpendicular bisector of the side BC. Step 3. The point where the 2 lines intersect is the circumcenter of the triangle. From point O, you can draw a circle that would touch all 3 points, point A, B, and C.
The Centroid. Centroid is the center point where the 3 medians of the triangle intersect. What's cool about the centroid is that it is the center of gravity. So for example, if you have a pencil placed on the centroid, the triangle will balance on top of the pencil. First, you find the perpendicular bisector of the segment AB. Extend the protractor to the length of the side you are working with. Now, make an arc on the top and the bottom of the side. Next, switch the leg to the other point of the side and make an intersecting arc on the top and the bottom. Finally, use a straight edge and draw a line from where the 2 arcs meet to the opposite vertex. Repeat the same steps for the other 2 segments. When finished, you should have 3 lines meeting in one place, and that is the centroid.
The Incenter. First, choose one of the corner from the 3 vertices to work with. In this video I will be using vertex A. Using the leg of a compass, you mark the chosen vertices and adjust the hinge to extend the pencil further to mark the 2 sides adjacent to angle A with equal length. Remove the compass and place the leg on the marked side and create an arch. Repeat this on the other marked side and create the same arch to intersect the previous arch. Using a straight edge, draw a line from angle A to the intersection and extend it. Apply these steps to the other 2 angles to find the incenter. After you find the incenter, you can draw a circle using the point inside the triangle. The circle will touch all 3 sides of the triangle.
The centers of the triangles can be used several different ways in real life. For example, the incenter can allow us to place an object equidistant from the sides of a triangle, like a triangular road. Say a park has a triangle road, and the builders want to add a fountain equally distant from each road. They would find the incenter of the road to do so. If there were 3 trees in triangle shape in a park, and the builders wanted to place a bench equidistant from each tree, they find the circumcenter of the 3 trees.
Often, students get confused with the 4 different types of triangle centers, which causes them to confuse the steps. Also, a common mistake is when a student's protractor slips on the paper or moves without them realizing. That can cause them to not get intersecting lines for the triangle centers since the marking will be off.